In the following video, we're going to examine the second method, the second approach to solving quadratic inequalities, and that is by factoring. When using the factoring technique to solve a quadratic inequality, what you want to do is you want to treat the inequality as if it were an equal sign, and then factor it to find the solutions. You use those solutions on a number line, and from those, you pick your 3 points on the number line, and you test each region to determine where the inequality is true, where the solution exists. So the bottom line is you're going to factor it as if it were an equation. Take your solutions, mark them on a number line, and in those 3 regions that are created, pick test points to determine where the solution space actually exists. So let's try it out. We want to solve y is less than or equal to x squared minus 6x minus 7. So we are going to treat this like an equal sign, like an equation. And so really, it's like treating it like it is y, well, you could say x squared minus 6x minus 7, y equals that. So to solve, you set the y equal to 0, and you factor. So x squared minus 6x minus 7 equals 0. And so to factor, we need to find numbers that multiply to give you negative 7, but add to give you negative 6. And so that would be negative 7 and positive 1. And so my factored form is x minus 7, x plus 1. And so I factored the inequality, and now I'm going to find the solutions for it. Set each one equal to 0. X minus 7 equals 0. X is 7. X plus 1 equals 0. X is negative 1. And so those are my solutions if it were an equation. And so what I'm going to do is I'm going to mark those solutions on the number line. So we're at negative 1. And you have positive 7. And what you do is you pick a test point in the regions. So pick a number that is, here's 3 regions. A number to the left of negative 1 is negative 2. Between negative 1 and 7, a good number is 0. And between 7 and beyond, a good number is 8. And I plug those into my original. I have x squared, so I have negative 2 squared minus 6 times negative 2 minus 7. So that's 4 plus 12 minus 7. 16 minus 7 is 9. The original inequality said that y is less than that expression. So is, 0, because you put 0 in for y, is 0 less than 9? And that is going to be true. 0 is less than 9. So that means this part is a solution space. If I were to plug in 0, you get 0 squared minus 6 times 0 minus 7. So 0 minus 0 minus 7 is negative 7. And so is 0 less than negative 7? And that's false. So this is not part of the solution space. And I do the same thing for 8. 8 squared minus 6 times 8 minus 7. So 64 minus 48 plus 7, which is 9. And so is 9 greater than 0? Is 0 less than 9? And that is true. And so this is part of our solution space. I mean, that's not your answer, though. This identifies your answer. Your answer is based off of what we had. The original answer, remember, is, y is less than. So less than, you use open circles. And we had solutions at negative 1 and 7. What this is telling me is that my solutions are to the right of 7. They're greater than 7, and they're to the left of negative 1. So they're less than negative 1. So my solutions for this is x is less than negative 1, or x is greater than 7. Before we move on to the next example, what we want to do is we want to analyze what this truly means and find some patterns from it. Remember, parabolas are U-shaped. And so what's going to happen is you should have noticed is, we picked, 1 unit away from negative 1. We picked negative 2. We picked 1 unit away from 7. We picked 8. And what you should notice is we have the same exact inequality here. You know, if this outside is true, if you think about a shape of a parabola, and I know this one based off what the original equation was, is opening upwards. Let me just go ahead and draw a basic parabola opening upwards. I mean, if this side is true, if this side is part of the solution space, then isn't the right side going to be part of the solution space? Because that means the outside is being shaded. And so what happens if this side becomes true, then that automatically means this side is going to be true. And it's vice versa. If this side were to be false, what that means is this is not part of the solution space, which means, you know, if you follow it all the way around, that right side is not part of the solution space. And so you can kind of, I would say, do this process a lot quicker without using all three test regions for it. And we're going to try that in the next example and hopefully develop our understanding of it. So let's look at example 2. We want to solve the following by factoring. And so I treat it as if it were an equation. I have x squared minus x minus 12 equals 0. It's a trinomial with a leading coefficient of 1. So you want factors of negative 12 that add to give you negative 1. And that's negative 4 and positive 3. So your factored form is x minus 4 times x plus 3 equals 0. So your solutions, x minus 4 equals 0 is 4. X plus 3 equals 0 is negative 3. So I have my solutions, and what I'm going to do is I'm going to mark those solutions on my number line. And so I have a solution of negative 3. So here's negative 3, we'll say. I have a solution of 4. And what you can do is you pick your test points. So to the left, negative 3 is negative 4. Between negative 3 and 4 is 0. To the right of 4 is 5. Now, in the previous example, we did all three test points. And we noticed there was a little bit of a pattern, though, in our answers. So let's try and apply that pattern. I'm going to choose the easiest number to plug in, which is 0. If I take 0 and square it, because it's x squared minus x, so minus 0 minus 12. You know, the original problem says it has to be greater than 0. So is negative 12 greater than 0? And that's false. That means this is not part of the solution space. So what does that mean about the outsides? If this is not part of the solution space, then shouldn't that mean the outside ones are part of the solution space? That my solution starts at negative 3 open circle because it is greater than, not greater than or equal to, and it goes to the right, and it goes to the left. And so my answer is x is less than negative 3 or x is greater than 4. And if you want, you could test the point. X squared, so 5 squared minus x minus 12 should be greater than 0. So 25 minus 5 minus 12 is 8. 8 is greater than 0. But you notice I didn't have to do that. I only had to test one point. If you think about it, didn't we only have to test one point on our graphing examples? So there are some similarities. Test one point. If it's false, that means the other ones have to be true. If it's true, that means that the one on the outside has to be true as well. And then the inside's false. So there's a shortcut. If you don't recognize the shortcut, then use all three test points to find the solution. So remember, for graphing, for solving a quadratic inequality by factoring, what you want to do is treat it like an equal sign and just factor and solve like you normally do. The new concept is take those 3 points, put them on a number line, and then do test points from there to determine where the solution space is. So we're now applying our factoring techniques to solve quadratic inequalities.